Hey guys, Dr. Kruse here, elementary statistics. Let's do a short video on probability given a table. All right. So for example, this little table right here has two airlines, and Podunk Airlines has 33 flights that arrived on time and 6 that arrived late. Upstate Airlines has 43 flights that arrived on time and 5 that arrived late. Now the first thing we do with these tables is we total the column, total the column, total the row, and total the row, and then both the row totals and the column totals should add up to the same grand total. So I had 76 flights that were on time, 11 flights that were late. I had the 39 flights that were Podunk Airlines. I had 48 flights that were Upstate Airlines. And both ways that I add those should come up to 87. So 76 and 11, that's 87, check. 39 and 48, that adds up to 87, check. So the first thing you do, given a table, is total everything up. Now let's say, for example, we were asked to give the probability that a flight, drawn at random out of a hat, let's say there were 85 flight numbers in a hat, and I shake up the hat and I pull one out. What's the chance that I pull out one flight that was on time given that it was Upstate Airlines, okay? Given that changes everything. This changes our total. Given that we are only talking about Upstate Airlines, we're no longer talking about the total 87 flights. Given that we're only talking about Upstate Airlines, well, how many flights was that? That was 43 and 5, that's 48. So given that we're only talking about these 48 flights, how many of those were on time? Well, out of those 48, 43 of them were on time. All right, so let me get this moved here. There we go. So 43 out of the 48 arrived on time. So there's a 90% chance that if I only have 48 names in the hat or 48 flights in the hat from Upstate Airlines, there's a 90% chance that their flight arrived on time. So the probability that a flight arrives on time, given that it was an Upstate Airlines flight, is 90%. They have a 90% on-time arrival rate. What's the probability that a flight was late, given that it was the same airlines? So given that, this is going to be kind of our fraction bar, and this will be the bottom number. Given that we're only talking about Upstate Airlines, these 48, how many of those were late? Well, 5 were late out of 48. All right. And when you're just talking about on time versus late, well, they should add up to 1. That kind of makes sense. All right, using the same table, let me scroll down a little bit. All right, let me rearrange the words a little bit. What if I ask you, what's the probability you draw an Upstate Airlines flight, given that you're only looking at the late flights? So we kind of switched the words around. Probability that you drew a flight out of the hat that was an Upstate Airlines flight, given that the only things in the hat were the late flights. So given that we're only looking at the late flights, back up here, okay, how many late flights were there? 11. So given that we're only looking at the 11 late flights, how many of those were Upstate Airlines? Well, out of those 11, 5 of them were Upstate Airlines. So 5 out of 11, which gives us 0.4545. So about a 45% probability that if you just put all the late flights in a hat, the chance of pulling an Upstate Airlines flight out of the hat is 5 out of 11, or about 45%. All right, what's the probability, or what's the odds that out of all the late flights, you grab a Podunk Airlines flight out of the hat? So again, what's in the hat? Those 11 late flights. How many were Podunk Airlines? 6 out of 11. So if you just look at the late flights, there's a 45% chance it was an Upstate Airlines, and there was a 55% chance it was a Podunk Airlines. All right, what was the probability that it was an Upstate flight, given that the flight was on time? All right, given that we're only looking at the flights that were on time, all right, what's the probability it was an Upstate? So given that we're only looking at the flights that were on time, we're only looking at these 76, how many were Upstate? 43 out of 76. So there's about a 57% chance that if you put all the on-time flights in a hat and reach in and grab one, there's a 57% chance that you'll grab an upstate flight out of the hat. What's the probability it was a podunk flight, given that you're only looking at the on-time flights? So we're still only looking at these 76. Well, that would be the rest of them. All right, so 76, given that we're only looking at the 76 on-time flights, how many were podunk? 33. 33 out of 76. So if you're only looking at flights that were on time, if that's the only flights that are in the hat, and you shake up the hat and you draw one out, there's a 57% chance that you'll draw an upstate flight, and there's a 43% chance that you'll draw a podunk flight. All right, I want to give you a larger table here. So we have the first row is people under 21, like college-age students, and they surveyed what their favorite pop was, their favorite soda pop. 40 under 21, under the age of 21, 40 liked cola, 25 liked root beer, and 20 liked lemon lime. So that's a total of 85 students. Remember, the first thing you do is you total your rows. What about the people from 21 years old to 40 years old? 35 liked cola, 20 liked root beer, 30 liked lemon lime, for a total of 85. What about the old folks like me, over 40? 20 liked cola, 30 liked root beer, 35 liked lemon lime, for a total of 85. Now those add up to 255 total. Let's make sure our column totals add up to that as well. 40 and 35 and 20 adds up to 95. 25 and 20 and 30 adds up to 75. 20 and 30 and 35 adds up to 85. And we grab our calculator and we add these three up, and yeah, they add up to 255 as well. So the first thing you do with the table is total your rows and total your columns, and then make sure your column total adds up to the grand total, as well as your row total adds up to the grand total. All right, so we have 255 total people were surveyed. Now what if I want the probability that a person picked at random out of a hat was over 40 and liked cola? So out of all the people in the hat, 255 surveys, so pretend there's 255 people in the hat, what's the probability I pick somebody out that is over 40 and likes cola? That's our AND rule. So the probability of over 40 and likes cola. AND rule is the multiplication rule. So that's the probability that you pick an old person times the probability, given that you're only looking at the old people, times the probability that person likes cola. So probability of cola, given that you're only looking at the old people here. This first one's out of everybody. So the probability that we pick an old person out of the hat, out of the 255 total, how many are old or over 40? It's these 20 and these 30 and these 35. 85 out of 255 are older. Okay, times. Now, this changes here. I'm only looking at the older people. I'm only looking at these 85 old people, 20 and 30 and 35. I'm looking at these 85. So given that I'm only looking at the over 40 crowd, how many of those like cola? All right, 20 of these liked cola. 20 out of 85. 20 out of 85. Okay, for a grand total of 0.07, rounds up to 0.08. That's about an 8% chance. Out of 255 names in a hat, there's about an 8% chance you'll pull a person who is over 40 and likes cola. All right, same table. Whoops, didn't mean to let you see that. Same table. What's the probability you reach into the hat? 255 names in the hat. What's the probability you reach into the hat and you pull somebody that's over 40 or likes cola? Or likes cola. So the probability that they're either over 40 or they like cola. There should be a better chance of this. So the probability that they're over 40, or is the addition rule. So the probability they're over 40 plus the probability they like cola minus anybody we accidentally counted twice. Minus the probability of the people who are both over 40 and like cola. All right, what's the probability we reach into the hat? 255 people in the hat. What's the probability we reach into the hat and grab an older person? 85 out of 255. We already did that one. Plus, what's the probability we grab somebody who likes cola? Well, how many people like cola? 40 and 35 and 20. 95 people like cola out of the 255 people in the hat. So plus 95 out of 255. Now, did I count anybody twice? Are there people who are over 40 and like cola? They got to be both. Are there people who are both over 40 and like cola? That's these guys right here. See, they're over 40, all these guys, and they like cola. These 20 are the only ones who are both over 40. They're in the over 40 row, and they're in the cola row. So these 20, we accidentally counted them twice. We counted them with the over 40 probability right here. We counted them in that 85. And then we also counted them in the cola probability. That 95, we counted them in there as well. So we counted these 20 people here and here. All right, we double counted. So we got to take out the extra count. So we got to take out 20 because we counted them twice. So there are 20 people who are both over 40 and like cola, and we accidentally counted them twice. Now, what if I ask you, what's the probability of pulling somebody out of the hat that's over 40, given that the only names in the hat are the cola people? All right, so given that the only people in the hat are the cola people, well, how many cola people do we have? We have 95 cola people. So let's put 95 names in the hat. And given that we're only looking at the cola people, how many of them are over 40? So out of 95 cola people, 20 are over 40. So it's 20 out of 95. 20 out of 95. So how many over 40? Given that we're just looking at the cola people, there's 95 of them. Out of those 95, 20 are over 40. All right, guys, and I think I'm going to stop there.